Okay, let's solve some quadratic inequalities. So step number one to solve quadratic inequalities, what we're going to do is find what we call critical values. The way we're going to find critical value is actually taking the inequality, the less than, and setting it equal to. Solve it like a quadratic equation. Minus 18, when moved to the other side, becomes plus 18. To get rid of divided by 2, to get rid of multiply by 2, we're going to divide by 2. To get rid of a square, we do plus and minus the square root of 16, which is 4. So this is our critical values, is at -4 and +4. And what you can do is you can actually take and pick a point, pick an x value in each of these regions and test it. We're not going to do that. I'm going to go ahead and get ahead of myself and show you that what we're dealing here with quadratics, you're dealing with parabolas. So those critical values is where your parabola is actually going to cross, and it actually separates your parabola into 3 regions. One region that's above 0, the middle region that's below 0, and the third region that's below 0 or above 0. So therefore, if we're looking for less than, we're looking for pretty much where is it less than 0. So therefore, we can use our symbol here, and we can know that this middle region is where it's less than 0, so we know exactly where our answer is going to be. Our answer is going to be everywhere from here to here. The way we're going to write that is x is everywhere from -4 to 4. We could write that as a sandwich. -4, try this, is less than x is less than 4. We could write it in interval notation, all the values from -4 to 4, not including them. Either one of those methods will be fine. Doing another, so we're moving everything to the left side. We always want our x values for these on the left side. I'm combining these. That gives me 1x squared plus x turns into minus x. Minus 12 stays put. And again, we're doing equal 0. But remember, our symbol's actually greater than. We'll need that at the end. So move everything to the left side. Next step is we're going to solve this by factoring. X and x gives you x squared. Adds to give you -1, multiplies to give you -12, be a -4 and a +3. Set each of these equal to 0 and solve it, and you'll get x equals +4 and x equals -3. So again, that's our critical values. When we place those on a number line, here is -3, here's +4. Make sure they're in order. Imagine that parabola that I drew a while ago, and think about where is it greater. Greater than means above, so that'd be everywhere from open circle because of greater than, not or equal to, and it's also above over here. So that shows you where your answers are. Everywhere from, and I'm going to write this one in interval notation, everywhere from -infinity up to -3, or everywhere from 4 to infinity. And the last one, again, we're moving everything to the left side. 5x squared, I'm going to subtract, and it gives me -2x squared. 3x, I'm going to subtract, it gives me +4x. Plus 6, I'm going to add, it gives me +6 is less than or equal to 0. Now, here's what I do to make things make more sense so that I don't have an upside down parabola. I'm going to go through, and if that first number is a negative, I'm going to divide everything by -1. Or in this case, since they're all divisible by 2, why not go ahead and divide everything by -2? That gives you 1x squared, -2x, a -3, and since you're dividing by negative, make sure you flip that symbol over and you get greater than or equal to 0. Again, remember that your symbol is greater than or equal to. That'll come in handy in just a second. We're going to solve this by factoring. You can use the Swinford method if you'd like to. X and x, -3, +1. My two critical values are x equals 3 and x equals -1. Again, imagine the parabola. It's going to cross at -1 and 3. We're looking for where that parabola is going to be above. And again, the parabola is going to be shaped like this. So it's going to be above over here. And it's going to be above over here. Anytime, again, you can think of it like this. Notice on the last two, anytime it's a greater than, it's always going to be this outside region is going to be the answers. It's always going to look like an or statement. And that's the reason I come up with this. A lot of times I'll say great or. If it's a greater than statement, it's going to be an or. And then if it's a less than statement, like in that first one, I'll say it's a less than. And an and statement is going to be the region in the middle. So therefore, if it's less than, and again, you can't have a negative here. If it's a less than, your answer is going to be the middle region. If it's greater than, your answer is going to be the outside region. So therefore, my answer here is anything from negative infinity to -1, inclusive, because the or equal to, or anything from 3 to infinity, inclusive. Final answer.